Hey guys, Mr. Palmer here with another AP review problem. This one has to do with galvanic cells, so we're going to talk a little bit about what these things are, talking about electrochemistry. You're going to see this sample problem up here. You can try it on your own, which is what I recommend. I'm going to put a link to a PDF of this document, a little bit better looking version of one, in the description, or probably somewhere on this page. I'll post a link that'll come popping up. So you can probably click on that, try it out on your own. I'm going to go through this step at a time. Maybe we'll split this into 2 or 3 parts so they're not too long. Let's take a look at what you got here. You've got a galvanic cell, a picture of one with aluminum and copper set up. You've got the salt bridge and a voltmeter and our electrodes. You're given a balanced equation that you're going to use for the overall reaction. And you're given some standard reduction potentials for a series of half reactions. And it says this galvanic cell explains that what it's constructed of, what the components are. And let's just go through this one at a time. So let's start with question A, or part A of this. It says, identify the species that is being oxidized in the reaction. Justify your answer. The place you really want to look is just at the overall equation, right? So it's going to tell us that in this case that aluminum is being reacted with copper. We see aluminum's going from being a solid to being 3+. So it's going from 0 to 3+, which means that it is going to lose 3 electrons in that process. If you look at the copper, you'll see that the copper is going from a +2 to 0, so 2+, and we're going to wind up with 0. In that case, it's being reduced. That is, it is going to gain 2 electrons so that the oxidation state goes down or is reduced to 0. So over here we've got oxidation, and up here we've got reduction. The two always have to go together. So to answer to this question, who's being oxidized, you really want to write carefully, it is the aluminum, right? The aluminum solid. It's not the aluminum ions that's being reduced. What's being oxidized is the aluminum atoms. Second part, it says identify which metal is the cathode in our galvanic cell. So here's our galvanic cell set up. We want to identify which one of the 2 metals, aluminum or copper, is in there. It says which one is the cathode. Well, we just have to remember what that goes with. And I gave you this way to remember it. Anox, right, sees a red cat. Reduction always happens at the cathode. Oxidation always happens at the anode. So in this situation, well, we only have to figure out where is reduction taking place. Reduction's taking place over here on this side with the copper, so our answer is going to be copper is. Justification, how would you justify your answer? You would simply say that copper is undergoing reduction, that is, copper is gaining electrons, and that only happens at the cathode. The second part says indicate whether electrons in the wire connecting the 2 half cells is going to flow from the aluminum to the copper or from the copper to the aluminum, and you want to justify. Well, one of the ways we remembered this was, right, fat cat. What did that stand for? That stands for from anode to cathode, right? That's the flow of electrons. Well, we already established that the anode must be aluminum because copper is going to be our cathode, so our electrons are going to flow from, who is our anode? That's aluminum, to our cathode, that is going to be the copper. So I would say that because the aluminum is being oxidized and the copper is being reduced, it must flow from the aluminum to the copper. That's enough justification in this case. I think I'll stop there. I'll come back and I'll finish the rest of this problem in a part 2.